Welcome to Mr. Mickleburgh's Maths World. Maths World. This is the way it is. We are continuing with graphs of exponential. I'm calling them functions now. Previously we were working with equations. And we were talking about dilations in the previous video. Now we're going on to translations. And translations are what I call shifts, really. You're shifting the function left to right, or up and down, or both. Okay, so let's have a look at a couple of those, a couple of those. So I want to plot this one. fx, the function equals 2 to the power of x plus 1. And I want now to introduce, or reintroduce, we know about this, the concepts of domain and range. The domain is simply the set of x values our function can have. So generally we think the other way, what cannot x equal for our function? Range applies to the y values in inverted commas because we're talking about function. So what values our function can have, what values our output can have. And the way we do that, answer this question, is to draw a sketch first, and it becomes fairly obvious fairly normally. Alright, so in the previous video we saw what y equals 2 to the power of x is equal to. We are not going to spend a lot of time graphing this, but we're going to pick our convenient points, maybe x equals 0 and x equals 1 again. Doesn't have to be those, but they're convenient. And when x does equal 0, our function equals 1 plus 1 is 2. So our y-intercept appears to have shifted up one spot, doesn't it? Because when we're talking about that function, fx equals 2x, 2 to the power of x I should say, when x is 0, the function equals 1. Okay, so let's pick another point. Let x equal 1. 2 to the power of 1 is 2, plus 1 is 3. So 1, 3, that might be a representation there. We could pick a negative value for x. If x is equal to negative 1, what have we got? 2 to the negative 1, we know is equal to a half, don't we? A half plus 1 is 3 on 2. So 3 on 2 is 1.5, that might be about there. So negative 1 is about there, and we've got our third point. So you can see we've got that coordinate there, that one and that one. And we need to fit a line through it, nice and smooth if you can, tailing off in this direction. Now, I've made that not too easy to see, but now I want to talk about the domain and range. Now, what we do, let's deal with the domain, so the possible x values that our function can take on. X can equal anything. It can equal any positive number, as small or as large as you like. 2 to the power of a billion is a very large number, plus 1, just a bit larger. Or even if it's negative, it's not a problem. If 2 to the power of an extremely negative number is just a very small number, plus 1. Now that plus 1 is also telling me something. It's telling me that, in fact, my function is never going to be less than positive 1, isn't it? Because if this is very negative up here, to repeat the point, that becomes a very small number, doesn't it? 2 to the power of something really quite large is equal to 1 over 2 to a very large number. Now 1 over 2 to a very large number, that's approaching 0, isn't it? So it's approaching 0, but I'm always adding 1. That means I've got an asymptote, by the way, which I'll sketch in a minute. Like there, I'll do it right now. And that occurs when fx equals 1. So, back to my domain. My domain is it can take on any values I like. Okay? So, there's a couple of notations you can use. You can say it's a member of the real number set, or you can use interval notation and say that, or even this notation here, like that. X is between negative infinity and infinity, and you could even use interval notation like so. This is not coordinate notation, Remember, when I use round brackets, it means you do not include the number. When you use square brackets, you do include. Now, negative infinity and infinity don't really exist, so we don't include it. So anyway, my domain, this is meant to indicate x can take on any value, any real number. Okay? Range is what I was talking about when I was referring to the asymptote. Remember, an asymptote is a line that a function will approach without actually reaching. And so my range is quite simply this. My function is always going to be greater than 1. Greater than 1. That's where my asymptote occurs. Okay, so that's a horizontal shift, vertical shift, up and down. You can imagine if my function was fx equals 2 to the power of x minus 1, this curve would shift down and I'd have an asymptote at fx equals negative 1. Okay, but the same, exactly the same curve, just shifted down. Okay, so that's vertical and horizontal translations. Now, vertical translations. Now to horizontal translations. I've got something like, if I want to shift something left or right, I add or subtract a number from my exponent. Okay? And it's quite simple to do. Counterintuitively, perhaps, if I minus 1 there, what's going to happen is that my exponential graph, my stock standard one, fx equals 2 to the power of x, will get shifted 1 unit to the right. Let's just see how that works. And of course, if it was a plus 1 there, I'd be shifting to the left. Okay? So, let's try this. Pick my convenient point again. If x is equal to 0, my function will equal 2 to the power of negative 1, won't it? And that equals a half. Okay? So I've got a coordinate to plot there. If my function equals another convenient point, might be, or x value might be 1, and when that's equal to, when x is equal to 1, I've got 1 take 1, 0, so 2 to the power of 0 equals 1. Okay, another coordinate to plot. And thirdly, only doing this because it's highly convenient, if I let x equal 2, I've got 2 to the power of 2 minus 1, so I get that, which is that. So I've got 3 good points. So plotting my points now, I have 0, a half, and let's just indicate a half there, 1, 1, and 2, 2 it seems. So make that, if not exactly to scale, a little bit to scale. Okay. You might appear I've got a straight line segment or straight line going on, but no, not really. So what I've got to do is put a nice, clean, smooth curve through my points and label it, of course. You always label them. That might do as a label for the moment. Now here, my asymptote, my horizontal asymptote is the x-axis. Okay? So when it is the x-axis, it doesn't actually appear there. So in answer to my question, state the domain and range of the function. Well, this is what we do. We say the domain, just trying to find a nice bit of clear space, there isn't really. Again, it's the set of all x values that my function can have, and there's no value for x that will not yield an output here. So the domain is all reals. I actually lately have been favouring this notation, the interval notation. Sorry about this whiteboard, it's not being very cooperative at the moment. The interval notation, so negative infinity to infinity, and that positive should not be there, sorry, uppercase R, because it can be negative. And my range, now let's think about this. What values can my function have? Well, there's my function axis there, and it is approaching, this function is approaching 0 in that direction, and it won't ever reach it. So the range is quite simply this: f dash x is greater than 0, can't equal 0, so that's my range there. And that's pretty well how you do translations. Thank you.